The kinetic molecular theory describes the behavior of gases. Gases have a lot of space in between them, and because they have a lot of space between them, they're not affected by intermolecular forces, which we'll cover a little bit more depth later. So as a result, the kinetic molecular theory was developed to explain the behavior of the gases. When we're talking about the kinetic molecular theory, there are four major talking points which we will address. Each of those points make assumptions, and those assumptions break down when you're talking about liquids and solids. Though certain parts of the kinetic molecular theory apply to solids and liquids, it's not as clean of an application as it would be to gases due to the fact that intermolecular forces actually will counteract some of the kinetic molecular theory. The first thing that we look at when we're talking about the kinetic molecular theory is that gas particles have a great or a vast volume, meaning that they're going to completely fill their container. And a container can be anything from a bottle all the way to a room to the universe itself. So what we do with the size of the particles, because there's so much space in between them, is we actually assume that the actual volume taken up by an individual gas molecule is zero. So zero molecular volume. So basically what we're saying is there's so much space in between the molecules that the actual volume of the molecule itself is negligible. It's close to zero in that comparison. At 0 degrees Celsius, the distance between gas molecules is 11 times greater. This is between is 11 times greater than the diameter of a molecule. Now that's at 0 degrees Celsius. As you increase the temperature, you increase the distance as well. The second major tenet of the kinetic molecular theory is that gas molecules are in constant random motion. Now it's important to also note that this motion is also straight line motion. They don't curve, they don't turn, they hit each other, okay? And those collisions with the walls, that's what we call pressure. So anytime a gas molecule hits a wall or an outside of its container, that is called pressure. The more collisions with the wall, the higher the pressure. The lower collisions, or less collisions there are, the lower the pressure is. All collisions are also considered to be elastic. Now what this means is that no kinetic energy, no energy of motion is gained or lost. It would be kind of like if two people were lined up right across from each other, this guy here and this guy here, and they ran at each other as quickly as they possibly could, and they collided. And after they hit each other, they didn't fall down into a crumpled heap on the ground. Rather, what would happen is they would both leave away from each other at the same exact velocity as if they hit each other. So what this is basically saying is it's a contradiction to everything we know. For example, if I were to line up across the room from one of you guys and run as hard as I could, and you ran as hard as you could, and we were to hit each other, in all likelihood I would run through you, you would be on the ground, and I would probably be on the ground too after we hit. The point being, though, our collision is inelastic, meaning that we're going to lose some energy in the process. I'm not going to be moving at the same speed once I collide with you. Gas molecules are different. Because they're moving so fast, they're going to not transfer any kinetic energy. The last thing we're going to address with the kinetic molecular theory is that at any given temperature, gas molecules have a wide range of kinetic energy. Temperature is the average kinetic energy. So if you look at, say, like a class average of grades would be the culmination of multiple people's grades being added together and then dividing by the number that you have. That would be akin to a temperature. However, if you look at each individual student, every student has a slightly different score. Their scores would be alike to the kinetic energy. Now, an important thing to note is that a low kinetic energy deals with substances that have a low temperature. High kinetic energy is a higher temperature. So when you have a higher kinetic energy, you have gas molecules further spread out, and they're moving faster. So they're more spread out, and they're moving faster, and they're going to have more collisions. However, a lower temperature, their particles are going to be closer together, more condensed, and less collisions.